Okay, class, I thought I'd offer up balancing equations practice for you, and what I did is I loaded one of the sample sheets from that we've been using in class, and just for a review for you, if you're still having trouble with it, I'll take you through balancing, I believe, these 10 equations that we have here. So first of all, when I approach these problems, I start from the left side, the reactance side. Remember, we have reactance over here, reactance on this side, and the products over here, okay? And the law of conservation of mass says that what we start with is what we end up with, and that's what involves the process of balancing, okay? So, to do this then, what we're going to look at is on this side, silver. I'm looking at this molecule right here. Silver, I have 1. On this side, on the product side, I have 2. So the only thing we can do, manipulate, is add coefficients. We do not touch these subscripts. Okay, it tells us how many parts we have, but we do not change them. We add coefficients to balance the equations. So again, 1 part silver on this side, 2 parts on this side. So the only thing we can do is add a 2 here. Okay, now this coefficient of 2 has impacted the second part here, my iodine. So I now have 2 parts iodine. I go over to the product side, and here I have 1 part. So again, the only thing I can do is add a 2 here. I now have 2 parts iodine. Okay, now I go on to the next compound, which happens to be sodium, and I have 2 parts. The subscript indicates that I have 2 parts sodium. On my right side, on the product side, I now have 2 parts because of this coefficient of 2. This 2 is applied to this whole compound. All right, so 2 parts sodium. And I have to balance the other element, which is sulfur. I have 1 part on this side and 1 part on this side. So that's balanced. I go back out and do a final check. I look that I have 2 parts silver, 2 parts silver, 2 parts iodine now, 2 parts iodine because of this coefficient of 2, 2 parts sodium, 2 parts sodium because 2 is applied to this whole compound, 1 part sulfur, 1 part sulfur. I'm now balanced. Okay, moving on to the next problem. Let's see if I can scroll down here. One second here, I gotta get off of the ink layer. Scroll down. Problem number 2. I look at, I have 3 parts sodium. On this side, I have 1 part sodium, so I need a 3 on the product side. Then, when I approach these problems as I've been stating in class, I look at this PO4 is phosphate. Remember this from the last chapter. If you need to go back and copy down or memorize those compounds, those oops, I don't know what happened there, those extensions. So, in other words, I have phosphate, and I have 1 part phosphate. I look across in the product side. Did that come through intact? Yes, it did. It's right there, and I have 1 part there. So that's balanced right now. I have to put my 3 back in here. Okay. Then I move on to the next part. I have 1 hydrogen part. On the product side, I have 3, so I'm going to need a 3 here. Now, that coefficient of 3 has impacted the chlorine. I now have 3 parts chlorine on the reactant side. If I look over to my product side, I also have 3 parts chlorine. It's right there. Okay? If I come back out and do a final check, 3 parts sodium, 3 parts sodium, right here because of that coefficient. 1 part phosphate, 1 part phosphate. 3 hydrogen, 3 hydrogen, 3 chlorine, 3 chlorine. I'm balanced. Moving on to the next problem, I have 3 parts barium here. I have 1 part barium here, so I need a 3 here right away. Okay, nitrogen, 2 parts. 1 part here, so I need a coefficient of 2. Okay, moving on to my hydrogen, I have 2 parts, excuse me, 2 parts hydrogen here. Here I now have, and you have to watch this, this coefficient of, or subscript of 2 means that everything in the parentheses is multiplied by 2, not the barium, all right? Not the barium, just what's in the parentheses. So I have 2 parts oxygen times 3 parts because of that coefficient. That coefficient applies to everything to the right of it, all right? So I have 6 parts hydrogen here and 6 parts here. So with a coefficient of 3 and the subscript of 2, we now have 6 hydrogen on this side plus another 6 hydrogen from here because, again, this coefficient of 2 applies to this whole compound, and with a subscript of 3, we have to multiply 2 times 3. So we have 6 plus 6, we have 12 hydrogen on this side. Okay, so to go back and balance this now, we need a 6 here. All right, now the oxygen. Now because of the coefficient of 6, we have 6 oxygen. The coefficient of 6 oxygen. And on this side, if you look, we have 2 oxygen from the subscript. Again, that subscript of 2 applies to this, everything that's in parentheses. 2 oxygen times 3 because of the coefficient is 6. Like I said, sometimes by balancing one part or one component of a compound, the other part balances. Go back out one more time and check everything. 3 barium, 3 barium, 2 nitrogen because of the coefficient, 12 hydrogen, and we went through this, 12 hydrogen, 6 oxygen, and 6 oxygen, so we're balanced. The next problem, let me erase some of this. Okay, next problem, and again, like I have been saying, you can put a 1 in here. If, for example, if I were to put this problem on a test and I left the blank spaces, I'm not going to ding you if you put a 1 here. Okay. Moving on to the next problem, we have titanium, 1 part. 1 part on the product side. 4 parts chlorine, 1 part chlorine, so we need a 4. Go on to the hydrogen, 2 parts hydrogen. Now we have 4 parts hydrogen, so we need a 2 here to balance. By putting that coefficient of 2, it affects our oxygen. We now have 2 parts oxygen, and on the right side of the product side, we have 2 parts. Go back and check it one more time. 1 part titanium, 1 part titanium, 4 parts chlorine, 4 parts chlorine, 4 hydrogen, 4 hydrogen, 2 oxygen, 2 oxygen. We're balanced. Problem number 5. Let me pull this up a little bit. Oops. Problem number 5. Problem number 5, we have 1 part calcium, 3 parts calcium. So right away we need a 3. Now we have 6 parts chlorine. Again, the subscript of 2 times 3 makes that chlorine 6. On this side we have 1, so we automatically need a coefficient of 6. Move on to the sodium. We have 3 parts here, 3 parts. And over here we now have 6, so we can put a 2 here to make that 6, okay? That 2 now has impacted this phosphate part, all right? The phosphate. Let me take the marker here. Phosphate. All right? We now have 2 parts phosphate. We move over here, and you notice that we have 2 parts phosphate because that subscript applies to whatever's in parentheses. So 2 parts phosphate and 2 parts phosphate. Come back out, see if we're balanced. We have 3 calcium, 3 calcium, 6 chlorine, 6 chlorine because of that coefficient. 2 parts, or we could say 6 parts, 6 parts sodium, 2 times 3. Again, the coefficient of 2 times the subscript gives us 6 parts sodium. Over here we have 6 parts sodium. Okay, then we have 2 parts phosphate and 2 parts phosphate. So we're balanced. Moving on to the next problem, problem number 6. We have 1 part sodium, 1 part sodium, 1 part bromine, 2 parts bromine. So we need a 2 over here. Okay, let's move on to the next part. Next compound, chlorine, 2 parts chlorine. So we need a 2 here. Okay, go back and check if we're balanced. And like I said, oftentimes in balancing one component, by balancing the chlorine, we automatically balance the sodium. So we can go back and check. 2 parts sodium, 2 parts sodium, 2 parts bromine, 2 parts bromine, 2 parts chlorine, 2 parts chlorine. We're balanced. The next problem, magnesium hydroxide plus this is hydrochloric acid. Magnesium, we have 1 part. We have 1 part here. Oxygen, we have 2 parts because of that subscript, 2 parts here. If we go over here, we have 1 part, so we need a 2 in front of there. Hydrogen, we have 2 parts here, 2 parts plus 1 part, so we have 3 hydrogen, okay? On the product side, we now have 4 hydrogen because we have 2 times the subscript of 2, we have 4. When I think 4 on this side, and I'll write that, 4. Over here we have 3, all right? To balance this, we have to think of terms of like a common denominator, or what number is 3 and 4 a multiple of, and that would be 12. So we have to think in terms of getting the hydrogen to 12, okay? So on this side, we have 2 here and the 1 here. We can, to get to 12, we can try different stuff, but sometimes it's more effective to go and look at, for example, the oxygen, which we have 2 of and 2 of, so that's balanced. So we have to take care of the hydrogen in this case, so 3 and 4, so we have to get it to 12. All right, so let's try maybe if we make this a 3. Okay, so now we have 3 times 2, we have 6, plus 1 is 7. That didn't work so good. What if we make this a, if we have 6, let's make this a 6. Okay, so we now have, let me get rid of that 3 down there so it doesn't confuse you. We have 6. We have 3 times 2 is 6, plus 6 is 12. On this side we have 4. But if we change this to a 6, we now have 12. Okay. So what we can look at is how did that impact everything else? Well, let's go back. We have 3 magnesium on this side, so we can put a 3 here to balance magnesium. We now have 6 oxygen because we have 3 times 2, and over here we have 6 oxygen. We have 6 hydrogen, 3 times 2 hydrogen plus 6 hydrogen is 12 hydrogen. On this side we have 12 hydrogen. All right, so that balances, but we have to check our chlorine now. We have 6 chlorine on this side, and we have 6 on this side. Now, one final step we can do is, just like a math problem, you always want to divide to your lowest common denominator, so we can factor out a 3, make that a 1. This becomes a 2. This becomes a 1, and this becomes a 2. Okay. All right. And how come that didn't work the first time? Because we were working with the differences in the hydrogen, but we can go and see if this balances. We have 1 magnesium, 1 magnesium. We have 2 oxygen. We have 2 oxygen. We have 2 hydrogen plus 2 hydrogen is 4 hydrogen. Over here we have 4 hydrogen, the 2 times 2. We have 2 chlorine. We have 2 chlorine. So it balances. Problem number 8. Iron. Iron. We have 1 iron. We have 2 iron. So we need a 2 here. Okay. Then, because we put the coefficient of 2 there, we now have 2 sulfur. On this side we have 1 sulfur. So we need a coefficient of 2 to balance the sulfur. Oxygen, we have 2 on this side. Over on this side we have 3 plus 4, because 2 times 2 is 7. So 7 and 2, we need to get to 14. To do that, you can put a 7 on this side. On this side, we can try 7. How about if we change this to a maybe a 4? We now have 4 times 3 is 12 plus 4, that's too big. Okay, so let's try possibly a 2. Okay, we have 6 here, 6 now, and 4 is 10. We need more, so let's change this to a, how about if we change that to a, we have 6, how about a 4? All right, we now have 6 oxygen plus 8 oxygen is 14. Okay, so that's balanced. Go back out and check again. We have 2 iron, here we have 4 iron. So we need to change this to a 4. 4 iron, 4 iron. 4 sulfur, 4 sulfur. And again, by balancing one component, we actually balance the other part. So 4 sulfur, 14 oxygen, and we have 6 oxygen, 6, oops, plus 8 is 14. So we're balanced. Okay, I'm going to move on to problem number 9. Problem number 9 and 10. Problem number 9, we have 1 phosphorus over here, and what we have to look at is, here's that phosphate, but we didn't start with phosphate on this side. This reaction formed phosphate here, but it didn't start over here, so we have to balance those independently. Okay, so we have 1 phosphorus, we have 1 phosphorus. Okay, we have 5 chlorine, we have 1 chlorine, so we need a 5 here. Okay, we have 2 hydrogen, and on this side we have 3 hydrogen plus 5 hydrogen is 8. so we need a 4 here. Okay, now we have 4 oxygen. All right, 4 oxygen, and here we have 4 oxygen. It's right here. Okay, go back and see if we're balanced one more time. 1 phosphorus, 1 phosphorus, 5 chlorine, 5 chlorine, 8 hydrogen. We have 3 hydrogen plus 5 hydrogen is 8 hydrogen. We have 4 oxygen, and we have 4 oxygen, so we're balanced. The last problem, we have 2 carbon, we have 1 carbon, so we need a coefficient of 2. We have 6 hydrogen, and we have 2 hydrogen, so we need a 3. Make that 6. We have 1 oxygen plus 2 oxygen is 3 oxygen. On this side now we have 4 oxygen, 4 plus we have 3 because of that coefficient again. Here's a classic case again of the 7. We have 7, and here we have 3. This one's going to be a little bit more difficult. So 7 and 3, I'm thinking in terms of 21. How do we get to 21? Well, we can say, let's multiply this by maybe 8. And again, a lot of balancing is trial and error. So we have 16. And like I say, we're trying to get to 21. Okay, so we have 16 on this side, and actually we have 17. 16 to get to 21. If I make this a 5, now I have 16 and 5 is 21. Okay, on this side I have 4 and 3. What if we change that to, let's try and how about an 8 again? Let's try 8. Right? So that gets us to, that 8 gets us to 16 oxygen, and 3 oxygen is 19. We need to get to 21, so what if we change that to a 5? Okay, so now we have 21 oxygen. So we have to go back and look at what did we change here. We now have 10 carbon. On this side we have 8 carbon. So we have to look in terms, and again, sometimes these problems are a little bit hard, so we have to change that. We have 10. Let's change this to 10. Okay, 10 carbon. We have 30 hydrogen. We have 10 hydrogen, so we have to change that. All right, change that to 15. All right, to get to 30. All right, so we can throw out this 16s, go out the door. So we have, now we have 5 oxygen plus 16 oxygen is 21. We still have that 21, but on this side now we have 20 oxygen plus 15 oxygen. We have 35. All right, and I may be doing this one wrong, but we'll check it. So we have 35. All right, so we have 21 to 35. All right, so it's still a multiple of 7 that we're working with. All right, so we're looking at a multiple of 7. Let's go ahead. Let's see, oxygen is the last part of that. So we have 5 and 16, 21. All right, so we're trying to get to 35. All right, so let's reapproach this one. Okay, this problem, those numbers aren't working. And oftentimes when you start getting up into like the 35s and that, might be a good idea to go back and check. All right, and some of you are going to say I did that on purpose. Well, let's go back and check. I have 2 carbon and 1 carbon. to get 2, I can put a 2 there. Okay. Now I have 6 hydrogen and 2, so I can put a 3 there, right? 6 and 6. Now I have 1 oxygen plus 2 oxygen is 3, and on this side I have 4 oxygen plus 3 oxygen is 7. But what if I put a 3 here? All right, then that's where I missed a step. That now gives me 6 oxygen plus 1 oxygen is 7, and I'm balanced. So sometimes, like I say, the trial and error thing comes into play. It often takes, go back and start over, as I did there. It wasn't that hard once I figured out. I think I had missed the oxygen originally. So there's a lesson in balancing equations. You will see this on a upcoming test, balancing equations, and hopefully this has helped you.